Okay, here's the pulley hub. It's always funny seeing catted parts come out for the first time because you don't really get a sense of scale until you actually make it. This is kind of smaller than I was picturing in my head, but it makes sense. I printed it out of TPU, which is a little bit of an unusual choice since it's flexible for what kind of part it is, but it's mostly solid, so it's not really bendable or compressible too much. And maybe that'll even help me have a good fit on the motor shaft, because I can kind of use this, like, compression of this to, you know, squeeze around that shaft and hold it tight. So we'll see. I also just didn't have like nylon or the PETG filament that I would use, so it was either this or PLA. So I figured I'd give TPU a go. Let's see if it fits on the motor. Okay, yeah, this works better than I expected, honestly. I was able to slide it on. Took a little bit of force, but it wasn't too bad. And yeah, it's tight enough that I can twist the motor with this piece, and there's like no give in it. Like, this twisting motion is like play in the motor itself. It's not between my piece and the shaft. So I might not even need these set screws. So that's pretty cool. Yeah, I'd say this piece is a pass for now. Okay. So this part comes out to 3 grams. It seems to hover 2.5, 2, it's getting lighter. 4, 3.5. I'll call it 3. So it came out to 3, and I said it was going to be 3.3. So pretty close overall, but a little bit on the lighter side. So if I change this to 3, yeah, so I could scale everything based off of this, but I think like the resolution of my scale isn't that great, so I'll just keep manually weighing things and updating this. We have a wheel. The hole for the shaft seems very small. I don't have a bolt to test it with, so maybe I should start ordering those kind of parts soon. But I don't know, did I make like a radius diameter mistake? I'm not sure. But anyway, let's weigh it. Okay. 13 grams. 14. 12 and a half. We'll call it 13. Let's see, what were my wheels coming out to? This is before I cut it in half. So 13, 52. Okay, so that's actually 10 grams over what I thought it would be. Not the best. It's very solid, so I could probably print this with less infill or less shell layers. But yeah, we'll just keep track of what's going on. It's also really slippery. I was kind of hoping that this stuff would be grippy enough on its own, but it can slide too easily. Yeah, we're definitely gonna need the O-rings. That means it will slide on the wheel shaft nicely, but it's not good for grip at all. Here's the wedge. Definitely a cool big piece to the robot. Kind of gives you a sense of the scale. that the whole thing is going to be, since this is the entire width. Print came out real nice. I was kind of worried because I had to do some weird support stuff to get this to print right. And it took some work, but I was able to rip off the support material. And yeah, it's like, you know, it's rigid here where it needs to be. You know, the whole thing total is flexible, but I think that's fine. Even though this isn't actually going to be the leading edge, because I'm putting that thin plastic, like, it does super well. It gets under like everything. So happy about that. And I checked it earlier, and I think it's underweight compared to what we were expecting. So yeah, 21.5. 21.5. So over here, we were saying the wedge was going to be 23. Oh, that's blurry. There. So a little bit lower. We'll take that. Yeah. I also did something a little crazy and signed myself up for a competition that is happening in like a month. Yeah, so that's gonna accelerate things, but I really didn't want to wait a whole nother year, and the progress has been moving along faster than I had planned for. And really the final straw was the fact that this just kind of worked, like that this piece fit onto the motor shaft so well. After seeing that, I was like, you know, this robot's gonna work. So we now, instead of having 300 days to finish, we have about 30. So definitely an accelerated timeline, but now we get to compete soon. So the real goal now is just to finish, but I'm excited to do that. Got a few more parts going now, mostly these. So this is, technically it's the top plate now. I printed this one out. You know, it does what it needed to. I thought that this piece would be a good place to cut weight though. So I kind of thinned it out in these sections here at the top. Probably not getting a ton of direct hits here, so I think I can afford to cut weight that way. This one is surprisingly significantly more flexible than this one, but I think that's all right. It kind of gets rigid once the rest of the box is there, and then the base plate's gonna be probably not TPU still. I can kind of put it together now, which is cool, you know. There's stacks there. Oh, I gotta get the wheel in here. And then the pulley core. And then there's stacks here. And we got the wedge. You can see it. It's becoming a robot. I really need to order parts. I think that's the next thing for me, because I can't check anything else without having the hardware. One other change I made to save cost mostly is I resized these O-rings so that I can use the same ones for the tire treads as I use for the drivetrain itself. So the size I need for this is basically the same as the size I need for this. These can apparently stretch like super far before breaking, so I've undersized them a decent amount, so it should be stretchy for both of these and kind of account for it. I also realized I can change the width of, or I guess the height of the bot significantly. I was still kind of having a tall bot way back when I was having a weapon, and now I'm able to make it shorter. So that's going to cut down on weight. I've been measuring these things. It's kind of lining up with what I expected, but still overweight. So I think the final thing I'm gonna have to do is smaller battery. I've confirmed that this battery is much larger than what's needed. It's about twice as big as what I need. So I found same brand, basically the same thing, just less milliamp hours. So it's smaller, it's lighter. I'm gonna make that change, and that should solve my weight problem. I'll see if I end up making like the frame thinner because of the smaller battery. If I don't have to, I probably won't. I don't want to make any huge changes, seeing as I don't have a lot of time anymore. But that is where we're at now. So I do need to order those parts, and then we can really start checking things out. This went okay. I guess I'll talk about the bad things first. It's really hard to fit everything in here. The only way I was able to do it is because TPU is so flexible that I could kind of bend things open, which I kind of expected to have to do, but it's tricky. I mean, if it goes all together, it doesn't matter too much, but if something breaks, it's gonna kind of suck to replace it. Like, getting this motor out requires basically taking everything apart. So, not the best. The fit here isn't ideal. The tire here is rubbing against this piece. I did CAD a slightly updated version of this piece, and I don't remember what I changed. Maybe I made that interior thing smaller, and that'll fix that. Another problem is, in order to tighten this bolt, I really have to like squeeze these two together, and then that puts a ton of drag on the wheel. Or I leave it loose, but then the wheel gets pulled inwards towards the center shaft because of this belt kind of thing here. So really, like, this needs to be rigid, but because it's all TPU, it isn't. And then if I spin this, it spins the motor most of the time, which is good, but sometimes it can get, like here, it's just sliding the belt on the motor rather than spinning the motor. Maybe that's fine because I think the motor has more resistance to spinning than this wheel does. So if I drive the motor, it might not slip on the wheel, but something that's a little concerning. I don't think I'm going to try to address any of these problems yet. I want to finish 3D printing the rest of it and put it all together and drive it and kind of see what happens. Stuff that did work well, I think I got the O-ring sizes correct. It's kind of hard to put on, but it's not impossible, and then it seems pretty solid. I can adjust the pulley hub shaft diameters to make this fit however it needs to, but I think it's okay right now. This thing worked a little better than I thought it would. It, pivots with gravity and it gets stopped there. So that's nice. yeah, what else did we test? Things seem to be fitting well. I'm gonna cut this shaft eventually. Oh, one kind of annoying thing is these tiny bolts that hold the frame together, these ones, in there, those are M2s, and I managed to only buy M3 nuts, so I don't have anything that locks that down, so I'm gonna have to get those as well. Maybe I can find them at some random store so I don't have to pay for shipping again for just one part. But yeah, coming together. Had a couple ideas on updates. One thing, the pulleys here are pulling, or I guess the O-rings here are pulling these two wheels inward, so they're kind of at an angle, and that's because the hole here for this shaft that the wheel's on is larger than the bolt. And if I tighten it, I can tighten it like here, so now it's straight, but then the wheel doesn't spin. So two thoughts I had was, one, I can just make this hole a lot smaller, so then it's forced to be in that spot. Or I could put a more rigid plastic piece, like a tube, around the bolt so that the nut tightens onto the tube and then the wheel spins onto the tube instead of the bolt itself. That's a little more complicated. I think I'm just going to try to make this smaller first. And then maybe set this nut into the material instead of on the outside, like I did for the hinge on that one. Because these are just gonna come loose if I don't. Yeah. Well, here we are. Yeah, it's all the non-electronic parts, basically. Frames together, drivetrains together. The motors are in, but everything else is still over there. But yeah, I'm happy to see it come together. Putting it together kind of sucked. A lot of the bolts are very hard to get to once everything gets assembled. In fact, I had to drill holes in the side. You can see them there and there to get to some of the bolts in the inside. And you kind of have to like take the wheels on and off, and it's kind of a mess to put together. But it did go together. And I've said this before, but the fact that it's TPU means I can like bend things to, maneuver around and put it all tight together. But yeah. Before this top plate went on, it was very flexible, like I could twist the whole thing, but now it's like surprisingly rigid. So I think I'm just gonna go full TPU. I'm happy with how this hinge works, no matter how I flip it, I have a wedge, that's pretty cool. I'm a little worried about this loosening because I have to keep it loose in order for it to do this. So this bolt could like unscrew itself. That's a concern I have in general in the robot. And some other small changes I want to make. I have them written down. Mostly it's things that help put this together easier. But yeah, excited to see this. And next I'm gonna throw all the stuff in here and drive it around. Starting to put the electronics in. I just wanted to show that this is working. So spin the motor, wheels spin together nicely. The motor itself wiggles a little bit. It's like getting torqued by the force it needs to push the wheels, so maybe I need a better way to mount this so it's not floating, but happy to see that kind of running smoothly. Those bolts are already going to loosen themselves, so a few things to fix. Okay, I was afraid of this, but I didn't really leave enough space between the motors to fit the wiring. So right now the motors are pressing each other apart, which is kind of pressing this wall into this one. So now there's a lot of force squeezing on the wheels, and it's gonna make them have way too much friction. Like, they'll probably spin, but it's gonna put a lot of stress on the motor, and it's just gonna be slower. It's also like the whole thing is like torqued a little bit. Okay, so robot definitely needs to be wider. Just a little bit, hopefully. The reason I made this so narrow was, one, I felt like the robot was just large in general, but I don't really have a scale for how big it's supposed to be, but it also saves weight by just having, you know, less material. So I'm definitely gonna have to smaller battery, maybe cut weight some other places. Yay. This is the least fun part, in my opinion, is, you know, it's fun to design things for the first time. It's fun to come up with concepts. Testing stuff is awesome, but having to redesign because it didn't work the first time is my least favorite part. But I'm gonna keep going on this. I'll put the rest together, still try to drive it around, but I definitely know it's got some work still. Well, that's definitely how that's supposed to look, and the wires aren't cramped at all. On the plus side, I can see when it's turned on. So it drives. It doesn't go straight. This is supposed to be straight, so that I think it's because one of the sides is just more friction than the other. It's my guess, but I don't know. It's still cool. It's not the huge success that I was hoping for, but it's a step in the right direction. Still kind of fun. I wonder if it can scoop up stuff. Let's see. Okay, well, I can push it around. I'm not really getting under it though. Definitely need drive practice. I think that, like, knowing how to control this well is gonna make a huge difference. Like right now I'm kind of squirrely. Cool. Okay, update on where the robot's at right now. This first version of the robot is technically done, but it is not ready to compete. Not everything fits inside, and it's too heavy, and the drivetrain is too much friction. It's being squeezed together too much. Yeah, so there's a lot of redesigning to do. I think, so I signed up for 2 competitions actually. I think I'm gonna drop out of the soonest one because it's in like 3 weeks. And, you know, I could probably get it ready by then, but I have a feeling that it's not gonna be where I want it. And I don't wanna show up to the competition knowing that if I had like a few more weeks, it would be significantly better. Which is fine. I don't need to do 2 competitions right now. I just need to do the one. So I'm gonna drop out of that, the soonest one, and then it gives me basically another month. So I have like 7 weeks, which feels doable. It's hard to say how much time I'll have. Like some weeks I get a lot done, and some weeks, you know, I spend like 2 hours on it and stuff doesn't really change. Yeah. And thinking about like the redesign, like I had said that that's my least favorite part of this process, and I think the less time I have, the worse it is. Like, if there were no deadlines, then like this redesign thing could be kind of fun. It's like, oh, let's look at what didn't work, we'll redesign it, test it out again. It's like, that sounds kind of cool, but the fact that I need it to work soon makes it less enjoyable, because then it's just like, it feels like it's getting in the way rather than being part of the process. So yeah, some redesigning. This is, expected. That's why I wanted to just put everything together as fast as I could to see what was wrong with it. And then we'll shoot for competition number 2, which is like May 17th or something. So like 6 or 7 weeks from now. All right. See ya. Okay, I forgot to do this earlier, but now that all the parts are real, let's see how we're doing on weight. I have a feeling we're significantly over. So, wait. Something's wrong. Because this is pretty light. Huh? That's not the answer I was expecting. Everything's here, right? 2 motors, this, battery. We have like 50 more grams to work with. Is this zeroed? Yes. Wow. Okay. I'm gonna go part by part and see what piece of this is way underweight, because I was expecting to hit like 480 grams. But that's a nice surprise. I weighed everything out individually. I'm a little less confused. When I weighed it out individually and then added stuff up, it's heavier than when I weighed it all together on the plate, which doesn't really make sense. Somehow I gained 10 grams. And then the spots that the actual weight was significantly less than what I estimated mostly comes from the wires. I said wires were going to weigh 30 grams. That was way over. They weighed like wires plus ESCs, I said, was 38. Whatever. Anyway, it ended up being way less. And then the other one was the hardware, like all the bolts and stuff, also ended up being like 20 grams less. I think I ended up using less of them than I thought, but only a little bit. I don't know exactly where that came from. But it's a little more clear now. I think for this next version I make, I'm going to not worry so much about weight and just build it and then weigh it and see where I'm at. It's gonna get heavier, but I'm underweight without even getting the lighter battery. So if I'm overweight, I have a lot of stuff I can do. So I'm not really gonna worry about it. And if I actually have significantly extra weight and time, I might start looking into like adding a metal plate on the front of this wedge here. Or another good spot for one would be like here. Because when other robots drive up, they're gonna drive up on the wedge and then still smack their weapon right into here. So if I could, put some more armor in that spot, that would be nice. But we'll see if I have time for that. Yeah, so I had to take this all apart anyway because I'm gonna need to reprint a bunch of stuff for the next version. I hope my scale is accurate. That was another thing that could explain all this weirdness, but I'll just hope for the best. This took less work than I thought it would. I think I've fixed all the major problems that I saw with the first build of this. So it's wider now. there's more space between the motors here, so I should have room to fit the wires in and not be like pushing the motors apart. Next big thing is before, when I tightened this bolt, it squeezed the wheels and put a lot of drag on it. So now I have this tube, which I'm gonna print out of a non-flexible material, probably like PETG or something like that. So now when I tighten this bolt, it's going to compress this tube and hold these apart. And then the wheel itself here is smaller than the tube. So the compression of the walls won't be squeezing the wheel anymore. And then added some holes so I can access this bolt here from the outside without having to take the frame off. This is basically the holes that I ended up drilling into the other one. Still have to take the wheels off to get there, but that ends up not being too bad. What I can do is I can leave the centerpiece on and leave the the O-rings there, and then just kind of like rotate this wheel up and pull it out, do what I need to, put it back in, slide it in. It's not too hard. Maybe I should add a couple more holes because accessing these bolts was a little hard. But at that stage, like, I can kind of just pull the shaft out and bend this frame to get to it. It's not the worst. The only thing I couldn't do was getting these was difficult without this hole there. Some smaller stuff. This is the top, actually. So there were bolts here and here, but they were really hard to maneuver the nut in place. And also, once I tightened it down, I had no way to know if it was tightened down because I couldn't see it. So I just didn't know if it was even doing anything, and it seemed to hold together fine without them, so I removed those. And then some small stuff, like these were a little too wide, the nuts were falling out and things like that. But yeah, I can start printing all the new versions of this, and basically every part changed except for the center pulley core thing. But the wheels changed, this changed, the base plates changed, this changed, so gotta reprint a whole new one. But yeah, that turnaround didn't take too long, so happy about that. I guess we will touch base again when I have everything printed and ready to try a second time. Update on what's going on here. Started printing the new pieces after the redesign. They didn't print as nice. I don't know why. It's a new material, so it could be that. Maybe the print settings on it should be slightly different. I just noticed more gaps between lines here and a lot more stringing than before. So I'll mess around with print settings and see if I can improve that. But these look like they're going to work, but it's not ideal. There's a lot of resistance still between the shaft that the wheel spins on and the wheel itself. I could make this smaller, but I think a lot of the resistance is coming from the fact that there's stringy bits in the middle and it's just dragging on it. I could spin it, with one finger. It's not the worst, but it's far from free spinning. What I do like is if I put this in here where it's gonna go and I really squeeze this together, I can still spin the wheel just as easily as when it was separate. And that means I can tighten this bolt now without compressing the wheel to the point that it can't spin anymore, which was large problem number one. Large problem number two was that the frame was too narrow, so the motors were hitting each other, and this one's significantly wider, and because somehow the previous bot was way underweight, I'm not too worried about bigger, meaning being overweight. So I'll put this drive side together. I'm having to sand some stuff, like I printed these like here, and the bottom layer is always a little wider, so I'm kind of sanding it down. I could probably chamfer that bottom piece to make that print nicer later. But yeah, hopefully have this together again soon, and we can do another full test. I've got like 4 weeks left until competition day, which means I wanted to be done like 2 weeks ahead of time, just for not being worried and also for drive practice. So I got like 2 weeks to finish this. So it's cutting it close for sure. I ordered a lot of extra parts. Should I do this like this? So you're not just staring at that. I ordered extra parts, so I have at least one spare of every part on the robot, because I'm sure things are going to break, and it was kind of painful to spend a bunch of money on something I technically didn't need, but it's going to break, and I don't want to only go here and fight one fight. The battery is another thing that I'm still waiting on, because I couldn't get a second receiver because the place that I bought it from was out of stock, and that's also the place that the battery's from. I think I'm going to get the smaller battery just for even more weight, and because I don't need that big of a battery. But that still needs to be ordered. Put this together, and feels pretty nice. Wheels spin, nothing feels crushed. That looks like that's probably going to be enough space. So just gotta make the other 70% of the robot. Back at the fitting all the electronics in stage. They definitely fit better now that we have more width here. Still tighter than I thought it was going to be. And it's definitely not clean, and it takes some fiddling around, but it does fit, so could be worse. One concern I have is for like durability reasons. Here's the front of the bot, and like the whole point is to get the wedge underneath, but I think whatever weapon they have is going to smack right into here. And there's some give there, but if you hit real hard, I'm worried this is going to break. These could break, though. There's not much space there. It's not too bad. If I get hit in the back, that's a little bit of a problem. It might shove the battery into the motors. Like, that could break stuff. If I had more time and weight, like I could add another layer here so that that one would compress and not this one. Or maybe I could make like this out of a rigid material and then the softer outer layer so it compresses and then stops here. So the compression, takes the brunt of the force, and then the plate here prevents the remaining from transferring to the electronics. Just a thought for the future. It could be worse, like getting hit here, it absorbs it before really putting pressure on this. Like that piece can just kind of move around. I don't know if that's good design, but we'll see if it works. Yeah, I'll put the other wheels on and start driving around again. Hopefully hopefully we drive in a straight line this time. Oh, I didn't even mention it, but there's not a ton of stress in the middle here. There's enough space for those wires, so frame's kind of staying straight. So yeah, next is checking the drive feel. Hopefully it does a little better this time. I'm a little sad that I got myself into this situation where I know improvements that I could make, but I don't have enough time to make them. And I guess that's always true, but I feel like there's significant ones. At the same time, maybe the significant updates I want to make aren't even like the important relevant things. And by going to a competition and fighting, I'll learn that, oh, this thing that I didn't consider is actually way more important than the change I wanted to make. And so I would have just wasted time optimizing something that doesn't actually matter. And on top of that, the competition I'm going to is only like an hour and a half away from where I live. And I don't know when the next close one like that would be. So it's probably a good idea that I'm in this competition, even though it's going to make it so that this isn't 100% where I wanted it to be. But it's still, I was trying to avoid that, and I haven't. But that's okay. All right, here we are for round 2. Actually, let me show you this real quick. But it closed this time, whereas before I couldn't really fit the lid on. It's still kind of popping it up, but that's not the worst. That's why I'm having this be like the default orientation. So when I get hit here, it's fine, but here, like, I could see something catching that edge, so that's why this is gonna be the preferred way. Yeah, let's see how it does. So far, so good. Let's try full speed straight line. Okay, it's a little curvy still, but better than before. Before, like, the full speed straight line was like this. That feels pretty nice. It also feels faster than before. I think there's less drag on it. It would be nice if it went totally in a straight line when it was full forwards. I wonder if I can like tune anything for that. Yeah, this might be a pass. We might move on to like finishing touches now. Let's see what driving upside down is like. So now forwards is backwards. So I'm driving backwards now, so if I want to drive forwards, I have to backwards controls it. Oh, it is much slower this way. Why is that? Is it like a controller thing? Like, is it set to not give me as much reverse speed as forward speed? And that's why it feels so slow. Last time, I had to drive it backwards because I couldn't fit the lid on. So now it's much slower, whereas this way. Okay, so that's some control stuff I'll have to mess with. Let's check the weight while we're here. It's missing the wedge still. And the wedge was gonna be like 40 grams or something. So what, that puts me at like 410, and the limit is 453. So I actually have like 50 more grams to work with. And this is even with the heavy battery, which I was already planning on replacing. So I actually have a lot more weight. I should use it in some way. I wasn't expecting to have this. I could just make all the walls thicker in general. I could put some metal armor on like this front region and maybe on the wedge. Or I could add the double layer like I was talking about. Or I just be light. Once again, I'm surprised, even though I was surprised last time. Let's go over what's left to do. One is the switch. I've been avoiding putting in the switch. It's gonna go here, and essentially it's gonna let me turn the robot on and off by, you know, screwing the switch. I've been avoiding it because I don't know a great way to make those electrical connections without having to do some messy wiring stuff that I just don't want to do. Not because I don't want to do the effort, but because like my solution feels bad. And also I haven't like needed the switch to test things. But I'll have to figure that out because it's part of the rules, and also having to plug it in and then screw the lid on while it's on the whole time and then take the lid off to turn it off is annoying, and again, against the rules. So that's number one. Then print the wedge. Feel pretty good about how that's gonna work because that part worked fine last time. I have to do the thin plastic sheet at the front that I was thinking about for like maximum thinness. I have to figure out why this drives slower in reverse. That's actually a big deal because one of the whole points of this robot is that you can drive it should have thought about that. Drive it both ways equally. And if I'm just way slow when I'm upside down, that's bad. So hopefully I can change that. It should be the same. Like, motors don't care which way they spin, really, so I feel like it's got to be something with the controller. I'm hoping that I can give it, 100% both ways, rather than what it feels now is like 50% forward, or 100% forward is 50% backwards. After that, I still need to order the new battery and the rest of the replacement parts. I need to figure out how to best use like 50 more grams that I'm gonna have, maybe even like 70 more grams, which is significant. That's like 1/5. Maybe when I say it as 1/5, it's not that bad, but it's a lot of weight that I should utilize because that'll make the robot better. I think that's it. Oh, and then drive practice. And practicing being prepared for things to break and knowing what to do. And getting all my like equipment ready for travel and all that things. And I've been saying 4 weeks left for like a week now. So does that mean I have 3 weeks left? Okay, this isn't too bad. Essentially, I was already connecting battery to motor controllers, so I'm just going to put this in between, just kind of soldered it up together, and now the switch will interrupt the power. Yeah. Hopefully it holds together. I might have fixed the being slow in reverse problem. I was preparing to calibrate these, but I found that just by messing around with the toggles on here, it might be fixed. So the things that seem to control it are these two. So we'll look at this one for now. So if I go full forwards, full backwards, just based off of the pitch there, you can kind of tell that it's going the same speed. And then if I throw this toggle all the way up, now it's much faster forwards than backwards, and if I do it the other way, slow forwards, faster backwards. So I could either leave them centered Or I think I do go even faster when they're all the way up. So I might have to, if I get flipped over, like switch the toggles, which sounds a little annoying to keep track of. But if, center speed is enough speed, then that's fine. Maybe if I did do the calibration, it would make it so I don't have to mess around with the toggles to get maximum speed both directions, but at least I know how to make it not slow in reverse right now. And I printed out a new wedge. Pretty much the same thing as the other one, but wider now. And as you can see, I switched back to the blue material. So I tried to print this twice with this like tan stuff and it failed. And after switching back to blue, it printed perfect. So this material definitely doesn't print as nice, which is unfortunate. I'm kind of sticking with the toast theme, and I thought that this looked more like toast than fluorescent blue. But if I can't get good prints out of this, then I can't use it. I don't know where it is right now. Oh, it's right here. But yeah, like this didn't print out very nice. It's just been having more issues with this material. I'm glad it's not my printer. I was worried that my printer was slowly like losing its perfect printing abilities, but it seems to be fine. It's just this material prints a lot nicer. So that's good to know. Okay, so I was just driving it around and I smacked it into my Allen keys over there and it just immediately shut off. So that's not good, because that's gonna happen in a fight. So first kind of debugging a problem here to hopefully see what went wrong. Battery says it's still at 11.5 volts, and that's plenty. So it's not that the battery died. Plugging it back in, everything's fine. So that's good, but also bad because I don't know what the problem was. My biggest guess is my switch connections are probably bad, but they seem okay. Actually, they seem not okay, because messing around with this changes the timing of these lights. Yeah, it's dropping connection, so I'll have to fix that. Soldered this up better and put some electrical tape on it, so it should be much more secure now. This kind of stuff is why we want to finish the robot a few weeks ahead of time, and then we can test it and find all these problems, because this would lose us a match, and for a tiny reason like this. So good to find. Put the wedge on. The print for one of these sides didn't work out in the piece in the wall that holds the nut that this bolts onto. So I can't actually tighten that. So it's not great. And then like this doesn't fall down on its own. So there's too much resistance here. And I'm worried again about needing to loosen these up for this to fall, and then having the problem of it being so loose that it falls off. So this is a pretty important functionality piece of this design to have it not work. So I might have to do some rethinking about that. I have the weight now to do something a little different, like maybe I build this out more and get it in a way where I can tighten it without it preventing this from falling, similar to what I had to do with the wheels. that might be next. Because I did the switch, temporarily fixed the being slow in reverse problem. And I think after that was like order parts and find out how to use more weight. And I think fixing this is more important than those. A few things to check out here. Reprinted both of these with the new lock nut idea. Can't remember if I've talked about that. Essentially now it's a lock nut, so it can hold tight without having to squeeze on this. It's still a bit more friction than I would want. Like, you can see that it kind of gets hung up. It is falling down now. Earlier it wasn't. So I'm worried that when both sides are in, there's still going to be too much friction in here that this isn't going to fall down flat. So I changed it slightly. Printing a new one just gives it more room in here, more space between the parts, so it won't be as much friction, hopefully. So that's that. Okay, here's the robot as it is now, and I realized I never checked if my little bits sticking out here prevented it from getting stuck on its side, so I'm just gonna see if I can balance it, essentially, and if I can, then that's bad. But I think it's pretty round. And even if I got it perfect, I should be able to like jiggle the wheel motors and... Alright, so it's not gonna get stuck that way. What about this way? Yeah, I think we're good. Where else could I get stuck? Can I get stuck like this? No. Yeah, basically, no matter where I put it, it should always go back to wheels. So, that's good. Also, since this is basically all together now, we can do another weight check. Oh, that's in the wrong units. There we are. So yeah, basically 400 grams. And the limit is 453. So I have 50 extra grams to work with, which is a lot. Plus, this is with the heavy battery, and the new battery is like 20 grams lighter. So actually I have 70 more grams to work with. And my plan for that is I have acquired a random plate of steel. So I'm gonna cut this up into little rectangles and put it on the robot to use up that extra weight. So my first thought was that I would have 2 plates and I would interchange them between fights depending on who I was fighting. So like if I was fighting a vertical weapon, I would put the plate here, and if I was fighting horizontal, I'd put it on the wedge. But now that I'm thinking about it, this wedge is so low that the vertical or the horizontal weapon blades might hit this back wall instead of the wedge anyways. And I'm pretty sure there are no undercutters in the fight that I'm at, so I'm not gonna run into many robots that can hit this with their weapon, I believe. So I'm definitely gonna put the plate here first, and then if I have some extra time, maybe I'll make like 1 plate that can go on this. But that, putting the plate here has issues with the other things I wanted to do with this, so definitely start with this one. Just gotta cut some rectangles and put some holes in here to bolt it, put some holes in here. Shouldn't be too bad. I've heard that steel isn't actually the best armor choice. People are saying that titanium is the best, but that's very expensive. And then steel, they said, just kind of like deforms usually. Like, maybe it's better if I just make really thick TPU, but I want the possibility of breaking someone's weapon by them hitting me. And TPU is just gonna absorb everything. It's not gonna really deal much force back into their weapon, whereas hard metal plate could. And I kind of want to just see like sparks fly. So maybe this isn't the optimal choice, but I don't have a lot of time. It sounds fun, so I'm gonna do it. Sorry, sickness, talking hard. Be brief. This is still not loose. I think I'm gonna make it a little wider so that it shouldn't rub against this. And then I will add some weight to it by screwing some bolts from the back. And they're gonna be kind of useless except for adding weight. And that should help it always fall down. This works okay, but because it's a lock washer, it tends to just spin in the hole I made for it rather than tighten. So it's kind of tight, but I can't tighten it all the way, but maybe that's okay. Did the thing where I made this a little wider, put some holes in the back so I could put these bolts in it. That makes it heavier, and now it should fall flat every time. It's still not as easy as I want it, like here. I guess it's down in the middle, it's just a little bent right now. It's not as easy as I would want it, but I think it's gonna be good enough. In worst case, I'll like spray some WD-40 in here or something. It's gonna have to be good. I think we're approaching the point where I need to lock in the design and stop making changes, because I really want to do drive practice and also like test durability and make sure this thing can actually take a hit. So really, it's Thursday right now. I feel like this weekend I need to finish the design, make the final version. I have all the spare parts, so I'm actually gonna make 2 of them. And then that'll be what I show up with. And then, yeah, I should have 1 week to practice and then like 1 week to prep actually going to the competition. So this weekend is kind of it for design. This showed up, big box. It's another controller and receiver. I couldn't find just another receiver on its own. It was sold out. But I figured if I want a second robot, it doesn't hurt too much to get a whole second controller and receiver, like the Duo. So that's that. And then I ordered more of the small batteries, and they were cheap. So I just ordered a few of them. Yeah, that's that. Last design thing that I kind of wish I had time to solve, but don't. Maybe this isn't the best time to show it because it's not all built together, but yeah, I can't, get stuck like this, but I can get stuck like this against a wall. Actually, this I might be able to drive out of because the wheels could touch this, and if I drive, maybe it'll work its way out. I think this is the worst one. Because the back here is going to prevent the wheels from touching. So the design change would be have my back wheels actually sticking out so that if I'm like this, I can just drive away. The top is going to be harder. Maybe I can get stuck on that top too. I think the wedge is going to make that less likely. I've seen robots where the wheels stick out the back, and I'm like, that's a bad design. Or not a bad design, but ideally, you would want to cover the back if you have the extra weight in armor, and then your wheels are more protected. But maybe those robots were having their wheels uncovered on purpose to prevent this thing from happening. I don't know how common this is, but I don't know. It would suck to lose this way. Then again, that's a way to lose without breaking my robot. So if I'm gonna lose, this is a good way to lose, but I would rather not. These new batteries are so much smaller. I knew they would be smaller, but just seeing it is impressive. Let me weigh them out. So my old one, 68 grams. New one, 35. So about half as much. Huh, this must be like denser because I feel like that I could stack 2 of these up and it would be, maybe that's about right. Anyway, the only real difference between these is the milliamp hours. And that just kind of determines how long the battery lasts. And this should be plenty long for my short robot fights. I think like 3 minutes is standard. This should last the 3 minutes. This is gonna last like 8 minutes, and I don't need it to last 8 minutes, if not longer. Like, I've driven this thing for like 10 minutes, and it, you know, maybe lost 1 volt. So this should be fine, and it saves a ton of weight and space, which are both good things. This is the reason why we can afford to put the big steel plate on the front. And if for some reason it dies mid-fight, then I'll put this one back in and take off the plate, but I really doubt that's gonna happen. So this is a good upgrade. I think I have all the parts I need now to put kind of the final version all together. Gotta take all the electronics and put them in here, but I have all this printed now. And one quick side thing, I switched from like this X pattern in here to these bars because I wanted to make this stiffer, and it's, you know, it's plenty stiff in this direction because of these, but it was really flexible in this direction, and adding these thicker sections in this direction actually makes a big difference in how stiff it is. I was surprised by how much better this one feels than the X. But yeah, I'll put it all together and see how it is. So it's all together. As you can see, the wedge doesn't work again. This should be falling down. I think the reason is this bolt in here is rubbing it against this front face, and I hadn't tested that last time. So I'll just make this a little wider, and maybe I'll make everything a little wider again too, just to make sure. So that's not good. There are 2 other reasons why I'm not worried yet. One is WD-40 is my backup solution for if it doesn't work at competition. I'll try that. And 2, I kind of realized that like this thing isn't going to be gently like set down on its other side. Like, it's just gonna fall over, and that weight or force of it falling tends to make this fall to the ground. So if I make this, you know, a little easier, I think it's probably gonna work on competition day. Also, my electronics, as you can see, are just kind of a loose, jumbled up mess. I've seen a lot of bots with really nicely designed kind of interiors where every piece has a place that it could go. But I don't really have time for that at the moment. I'm also not convinced that that's necessarily more durable. It's probably better for fitting everything in and for like assembly purposes. But this might be plenty durable too, because like the whole robot's kind of squishy, and you know, if I get smacked in the back really hard, like the fact that this is all loose means it can kind of just push itself out of the way rather than getting crushed. And maybe that's a good thing. Maybe, you know, it being loose just means like nothing's really gonna have a ton of force on it. Or at least that's the hope. Since this is pretty much its final form now, let's weigh it and see how much of this metal plate we can afford to add. So, wow, it's light. That new battery did a lot of work. So 382. The limit is 453. There will also be some nuts to hold on that plate and some bolts. That barely makes a difference. And the plastic sheet that's gonna go on the front. $393, and then some cosmetic stuff. Usually that doesn't count towards weight, but I'll just add this. $395. Let's call it 400 for some buffer, which means I have like 53 grams of this to add. I could probably get away with 60. So 50 or 60 grams. Cool. That should be enough to have a decent sized plate on the front of there. I took off the bolts here for this wheel, and now this is real nice and loose. So that's good. All I'm really gonna do is make this channel in here wider, so it's not rubbing up against that bolt. And just a reminder, the whole point of that channel is so I can't do this, because then the robot could get stuck like that, which would be bad. So that bolt in there kind of prevents it from going any further than that. I'm hoping that when this gets hit really hard, it doesn't like get bent out of the way up and over the bolt, because that would essentially lose me the fight. But I don't think that's gonna happen. I think either this would deform a bunch, or like the force it takes to move this over that bolt, I think is gonna be greater than the force it takes to just flip the whole robot. So it should be fine. New edge, and this one falls real nice and smooth. So it was that bolt that it was actually hung up on. Got my plastic sheet on here, and this is gonna be a very nice and low, clean edge that should get under basically everything. So excited to test that out. I also found this sheet, which is like a vinyl sheet. It's more flexible, but it's potentially even thinner. And vinyl's pretty durable, so I had seen someone do this on a robot with these acetate sheets. I have not seen someone try this, so I was gonna give that a go as well. Probably the best way to test it is I'll build the second robot, and I'll make one of them be the acetate sheet and one of them be the vinyl, and I'll see like who can consistently get underneath the other robot when we go edge to edge with it. That'll be a fun test, but it doesn't look the prettiest, but there it is. I mean, that's gonna slide under a lot of stuff. Hopefully I'll win the ground game with it. I see a lot of people do like TPU forks or metal forks, So I'll have to come up with a way to check that out. Like, I don't have enough hands right now. So here it is driving around. You can really hear it scraping on the floor. It's low enough that it's actually like getting under this tape over here. Like, I can almost peel this tape off the floor. Yeah, not so much, but yeah, it's low, that's for sure. I'll have to see how smooth the floor of the arena is, because if it's bumpy or there's lips on it, then, you know, this could happen and I just get stuck everywhere. So there is a way to be too low to the ground. So we'll have to see. So for the other side, this, you know, this edge is still quite low, but now there's a second lip where the wedge meets the plastic. So my thought is I'll add another sheet like this. It's gonna be a little worse on this side because now you have two plastic sheets that need to get under, but I'll just have to live with that. I think it's better than like this. And I forgot to mention, but I just used some 2A tape adhesive. You can kind of see the two strips here, and that worked real nice. These sheets are kind of meant to be expendable. I'm sure I'll break one and have to put a new piece on, but that'll be nice and easy with something like this. While I wait for the opportunity to cut that steel plate, I might as well start testing. I'm gonna do some durability tests. I really don't want to break it, but I would rather break it now and figure out how to make that not happen than break it in a real fight. So first, I'm just gonna drive it into some heavy objects and see what happens. Because last time I did that, it turned off. So yeah, here we go. And we're stuck. This will also be good drive practice, so lots of reasons to do this, and it's fun. Alright, that's fine. Let's see what else I can come up with. Alright, here's a fun one. Drive it down the stairs. Let's see. I might get stuck. Oh no, I can cross that. That's good. Alright. See you later. Yeah, it didn't care about that at all. Kind of soft stairs, and it only made it about halfway. On second thought, I think that drill test wasn't quite the impact that it's gonna see, because I remember seeing robots get like knocked all the way across the battle arena, and that thing's like 8 feet across. My drill hit this maybe like 2 feet across the floor, so it's at least 4 times weaker than what it's gonna see, but still happy. Like, you know, the impacts were on the side, the back, did a few places. No damage at all. I wouldn't expect this stuff to get damaged, and all of this is made of the same thing. Electronics seem fine. Nothing seems loose, everything runs, so Good test so far. All right, got my plate made. Checked the weight and everything. It's gonna work out nicely. So this will be a nice, fun armor piece on the front. I'm gonna make a couple more. I'm borrowing my friend's shop with some nice tools for this kind of thing. So, yay. I'm not sure when this happened, but I just noticed that this unplugged from the motor. I don't think it happened during like all of the destructive testing I was doing, but unless it happened just now as I was like pulling on wires, I probably need to come up with a way to secure that better. Got the steel plate on the front. That's pretty nice. We can check the weight now that it's basically the full robot. 449. Yeah, real close. I mean, limit is 453, 454. So we're 5 grams under. Definitely pushing the limit. There you go. But it's under, so that's where we want to be. This plate in the front ended up being the heaviest of the 3 I made, so I'm glad that that one's puts us underweight still. It's kind of almost shock mounted, which is kind of cool because of those kind of TPU standoffs I put in there. I did those mostly for clearance with the other parts sticking out. But in a way, this is got some compression to it even before it puts force into the main body, which is cool. So that piece should be able to take a hit real nice and potentially deal enough force back to the thing hitting it to cause some damage, but we'll see. I really want to change these. The plan has always been to countersink these bolts, because if a weapon hits right on it, it's just going to shear the head off. And I can afford to have that happen a few times because I have 4, but these should really just be countersunk. The other problem is it's gonna, if the weapon hits this, it's gonna give it some real nice bite and probably throw me, whereas hitting this flat plate won't do as much. But there it is. I mean, this is very close to done now. That's better. I found some random flathead bolts lying around that are the right length, so made some countersinks. This is all pretty much nice and flush. I don't love how I did it. I essentially just drilled halfway through this plate with a bigger drill bit. So I'm gonna hold off on doing the same to these. Maybe I'll come up with a better method. But for now, this proves that, you know, in a pinch, I can just do this and we'll have nice countersunk holes. So my goal for this weekend was to pretty much finish the robot, and I think we got there. All the parts are in, all the major changes I wanted to make. Obviously there's some more stuff, but I'm just gonna cut it here. So as for what's next, it's gonna be make the second one and drive practice and maybe a little more durability testing. Hoping to do that throughout this week. So I got 2 weeks left. 2 weeks minus 1 day. And yeah, this week is gonna be build the second robot, drive practice, durability test. And then the last week is whatever I haven't gotten done, plus prepping everything to actually travel and do the competition. and maybe get some of my other teammates up to speed. Invited a few people to come to the competition. I think it's going to be helpful to have other people in the pits working on the robot if it's broken, or like scouting out who I'm going to fight against and things like that. So excited that they're coming. Right now, all my stuff is in a big old mess on this table. So I have to get it in transportation form. But happy to be at the stage where, you know, this is ready to fight 2 weeks early. That was my goal, and we made it. Like I said, had to make some sacrifices. There's a couple of changes I would have liked to have made. I think the biggest one is have the real wheels sticking out, so I can't get stuck against the wall as easily. But that's just too big of a change to make right now. But that's okay. There will always be another competition. Okay, I want to practice driving while interacting with another moving object. So my test is going to be push that orange ball and try to get it into one of these weights, which is quite hard. These things are fiddly, but that's why it's practice. Okay, I've learned two things. One, I think this test is way more fiddly than a real fight's gonna be. Like, this is very precision, and I think the fight is much more like run around in circles like a crazy person. Secondly, maybe I should have changed the geometry of the front of my robot to like be better at corralling things, because right now with the straight line, like, it tends to want to fall off the sides, whereas if my wedge was more like this, then things would stay in the middle. Maybe that's something I could change. I don't think I could do this though without increasing weight of the wedge, but I also have all those bolts in it to purposely increase the weight. So I could take them out and increase the weight and build something more like this, but I don't know if it works with my plastic sheet. We'll see. I'm not too worried about it. Worst case scenario, I could still push people. It's just I won't be able to push them in any particular direction very well, because I think they'll just slide off the sides. So, something to learn. Maybe I'll come up with a new test that's a little less precision. I might try this one backwards some more though, or upside down. Okay, I think I broke something. Yeah, I intermittently don't have left drive. So that's cool. Let's see what it is. Okay, this is a maybe needs a design change problem. What is happening is when I'm free driving, it was fine, but when I try to push something, it's putting a lot more resistance on spinning these wheels, and the motor shaft ends up spinning inside this pulley hub while the wheels don't spin. So when it's free like this, no problem, no resistance, everything's... Oh, Even here you can see it. How it's stopping for a second, but the shaft is still spinning. It's just that it's spinning, or what am I trying to say? The motor shaft is always spinning, but it's not always spinning the pulley with it. So that connection isn't tight enough, which is definitely going to be a design change of sorts. So maybe in these 2 weeks it'll be less practice and more find out what's wrong and scramble to fix it. But again, happy that I have the 2 weeks to do it instead of this happening in the first fight. So this part here is also made of TPU, like most of the robot. So I think the first thing I'll try is just print that out of something that's not flexible, and hopefully it'll prevent that shaft from spinning inside of it. I'm somewhat confident that that could work. It is funny though, that's the piece that's the oldest on this robot, or like every other piece of this bot had been given an updated design, so kind of makes sense that is the one that failed now. So maybe this won't be too bad of a fix. We'll see. Took the robot apart again so I can try the new hub out. This one, which was on the drive side, that was fine, still has a D-shaped hole, but this one now has a circular hole. So the motor must have rounded that out. I'm kind of surprised at how it was able to do that. These are TPU. This one is PETG. It's a lot harder of a material. So hopefully that means it won't get rounded out like this. But I'm still confused out what even happened. Like, where'd the material go? A little worried that plastic is just not going to cut it. And I don't know how to get this made out of metal. Maybe I'll have to go back to set screws. But I'm going to give this a shot. I'm hitting the wall of this stop being fun. I think it's the classic, like, not a lot of time, things aren't quite working. Feels a little more like a second job at the moment. It's a cool second job, but I think part of it too is that, like, the last 5 or 10% of a project isn't as fun, because the fun part is like figuring everything out and doing it for the first time and testing it. But then the last part of just trying to fine tune and make things work, like, it can be exciting if it is working and improving. But if it's not, like this, like, this didn't work, so, or the TPU one didn't work, so I made this. This is too big, or too small, so I made the hole a little bigger. That one's still too small, so I make another one, make the hole a little bit. Like, it's not creative. I'm not, like, testing anything super cool. It's just, like, work now, which is okay. I'll cross the line, but I am looking forward to not having to work on a robot. So competition's going to be super fun, and then I don't have to make a robot anymore. So we'll get there. This fits on here now. Feels pretty tight. I'll have to test it to make sure it doesn't do what that does later. I'm a little worried though that I broke this motor trying to shove on the ones that were too tight, because this motor shaft now is a little bit looser than this one. I think it's still gonna run, but I'm worried about it getting worse and breaking, or like performing slightly less and then my drive is unbalanced. And I don't really have the time and don't really want to spend money on another replacement part, so that would be very unfortunate if it's broken. But now this fits, so I can test that soon. So the idea here is if I can hold this and stop it from spinning while the motor is trying to spin, I can check if it's gonna just round out this hole again or if I'll be able to stop it. So let's turn it on and yeah, it's kind of hard to grab. This will be better. I don't think that's gonna go anywhere. I think that is solidly in there. We'll have to see, but I'm just gonna send it now. Quick note to self. This is the preferred way to do these belts versus this, because this way they clear everything, but this way this belt kind of maybe rubs up against that bolt. So there is a preference, and I accidentally did them differently each, but now I know that this way is better. And also one of these drive sides has a little more resistance to spinning, and I think, yeah, it's this side, so maybe it's because of that. I don't know how much that's really contacting, but yeah, that's it. All right, she's back together and can push a bag and other things, hopefully without breaking the motor shaft or the pulley. I think now the looks like the first thing to give is the traction on the wheels, which is good because that's not a destructive thing to give. I guess if I wanted maximum performance, I would prefer the motors to not have enough torque before the tires slipped. But right now I just want it to not be broken. Now that I don't have a lot of time, I'm kind of afraid to do really rigorous testing, because if I break something, I might not be able to fix it. Just finished printing a whole new wheel thing for the second robot, and these actually spin much nicer. Like you can get them to kind of free spin on their own just for a second, and the other ones were like dead stopping. I think it's because of the red material, or like this brand just prints nicer. So there's less bumpy resistance in there. So that's cool. I'll probably print another whole set of wheels and replace these ones with the nicer set. Give it some less resistance. And then I'm going through the electronics for the second robot again. I kind of don't remember how all of this works exactly. even though it's all right there. But I'm sure it won't take long to figure out. So here's the bolt that goes through for the wheels. And on these shafts on the other robot, I actually have to like screw this bolt into here. But this one is much looser. So I don't know if I changed the CAD and didn't know it or what. I might have printed this on a different printer actually. Either way, now this like free spins very easily because it can spin on the bolt. So yeah, that's like no resistance now, which is good. But also it's like a little wobbly maybe because of how much space there is. And the other robot, because I had to screw this bolt into here, this shaft was actually what's holding the bolt tight. Whereas now what holds the bolt tight is the actual nut that goes on the inside of the wall. And I've seen in the past when that nut is loose, it just falls off. So essentially I have to check that and make sure that that nut is enough to hold this all tight, because in the other robot, this shaft is actually the thing holding it tight. I do have lock nuts, and I think I have the space for them, maybe. So if the regular nut doesn't do it, I think the lock nut will. Good news, I have 2 robots now. Bad news, they can't really push anything. Yeah. Interesting news is it seems like the what was that? It's not nylon, it's vinyl. It seems like the vinyl sheet gets under the acetate sheet on average, but not all the time. But yeah, as you can see here, that one seems to be the lower one. So that might be the way to go. I can push this. No, I can't. Yeah. As you can see, I also changed up the wedge on this one. Not that I can really test it because I can't push anything, but it's got these walls on it and a little wider opening so that hopefully I can push and steer robots around instead of just straight. But I have to fix the no pushing problem. What happens is, also this one doesn't fall. I'll work on that later. The wheels just spin. I don't like have enough force or grip to actually push the other robot forwards, which is bad because that's about the only thing that this robot could even do. So if I can't push anyone, then I'm literally just a punching bag. Yeah. So I have like 6 days. We'll see what we can do with it. So to fix the pushing problem, we either need to get more grip or require less grip. For the get more grip way, I made these wheels. I'm still gonna put the O-rings in here, but they're gonna go in these slots, and I'm gonna chop them up and put them in sideways like this. And that will hopefully give it kind of more bite instead of just sliding on the slippery ring the other way. I don't know. It's an idea. I'm not super confident. As for requiring less grip, the thought is right now when I go to pick up another robot, like there's still a lot of contact with the ground, and that makes it difficult to push. So if I made this wedge huge and extended the plastic a bunch, maybe I could get under them enough that instead of pushing the other robot, I'm more carrying the other robot. Looking at this here, I mean, for that to work, my wedge has to be like this long, which is a bit ridiculous. So I don't know. I don't know how other robots do it. Like, my wedge is very low compared to theirs. Like, can I push you like this? I guess I can test that, but I don't think that would make a big difference. So I'm gonna try to make the ridiculous wedge, and a nice thing about that is if it doesn't work, I can just, you know, go back to one of these. Like, they're all modular. I can take them on and off, so I can kind of make some weird solutions and see what sticks. Alright, this just got weirder. I was trying to push Robot 2, or push Robot 1 with Robot 2, which doesn't work, but I can push Robot 2 with Robot 1, and it's not even that hard. So I have no idea why. Yeah. Very strange. These robots should be very much the same. Oh, this is cool. So I could only push them if I get under. But if I'm on top, it's a lot harder, which makes sense. I mean, that's the point of this wedge. So yeah, I'm gonna do some looking into what's going on here. So my first thought was weight, because Robot 2 doesn't have this plate on it. But it's not this, because I set this on Robot 2. Robot 1 could still push 2, but 2 couldn't push 1. So now I'm going back to this, and I said this wouldn't make a difference, but this is Robot 2 easily pushing Robot 1 once Robot 1 is higher off the ground. So now I'm wondering if Robot 2's wedge lifts up the robot less high, and therefore it can't push it. So I'm going to switch the wedges on the robots and see if the other robot can do the pushing now. It also seemed like maybe Robot 2's O-rings were a little more slippery than Robot 1. That could be because Robot 1's are more worn down, so I could like take sandpaper to those before a fight and get them extra grippy. But I'm going to try the wedge thing. Wedges are swapped, and one interesting thing is now that wedge falls and this one doesn't. So that means that it's the, I don't know, drivetrain section here that's causing this not to fall rather than the wedge itself. I thought it was the wedge because that's the thing that should be different, but now this wedge works fine on Robot 1 and this one doesn't on Robot 2. So I'm wondering if I accidentally printed an old file for this piece where that inner part was bigger, or the print just messed up or something. But that points me in the right direction, that it's not the wedge's fault for not falling down. So here we have Robot 2 pushing Robot 1, and kind of. Okay. Robot 1 pushing Robot 2. Also kind of. Interesting. So that means it's a combination of the wedge and the wheels. Where that wedge, the old wedge works better, and the old wheels work better. And together they make a big difference. Huh. I want to check this real quick. So, old wheels, 11.5. We'll call it 11. New wheels, or I guess current wheels, same, cool. $11. New wheels. 13. Okay. That's what I was afraid of. I think I'm accidentally printing these thicker than they need to be. It doesn't seem like a lot, but they don't have all the rubber on there yet, so, add a couple more of these. Let's see. 14 instead of 11. So that's an extra 12 grams. And last time I weighed the robot, I was 5 grams under, so I can't do that. Ugh. And I've already started cutting these up, so I'm gonna have to take them apart, and I wasted, the day of build time. So, lesson learned, don't rush ahead. I didn't expect this, but this wedge weighs 30 grams. And this one, it's a little less, but it's basically also 30 grams. I thought this would be heavier because of these bolts, but I guess this being larger used up all that extra weight. So going for giant wedge is really gonna use a lot of weight. I think if I do giant wedge, I can't have the metal plate anymore. But I also don't know if giant wedge is gonna be an extra 60 grams. So I'll have to find something to do with whatever I have left over. I guess knowing that giant wedge means I can't use the metal plate, then I don't feel so bad covering it up with the giant wedge, because I can't afford to have it anyway. Yeah, we'll print one, and we can always use these. Turns out that this piece was just printed badly, and I was able to kind of cut off the bad parts with this, and now this falls real fast and nice. So one problem solved. I also thought about switching from the wedge pivoting back here to having it pivot at a new piece right on the front, and that would save weight and also be higher up, lift like the other robot higher up. But I'm going to decide against it for two main reasons. One is it's kind of a lot of a change. Like, I need to change this piece and the wedge, and it's like kind of works totally differently. And I don't have a lot of time for that. And two, it kind of gets rid of the uniqueness of this robot. Like, there's another robot in this competition that looks very similar to this, but with the wedge at the front. And if I'm, just making a clone of that, I don't know, that's less cool. It makes me a little sad that, optimizing for a good design ends up making everything kind of look the same. But I guess that makes sense. Everyone's, trying to do what they think is best, and typically there is a best way. But yeah, I'm going to do it like this. Another problem with putting the wedge up front is it kind of removes the point of this metal plate. That's not here right now, but because it would just cover it and you would never hit it. And that too is like part of what I think makes this robot unique. I don't see many other robots out there with like a big metal plate at the front in the same way that I have it. And again, maybe it's a bad idea, but there's a trade-off between having the best design possible and having something that feels unique. It's a competition, but it's not professional. You're kind of here to have fun, so not working at all isn't fun, but no uniqueness also isn't fun. So you gotta find the balance. So these wheels don't really work. It seems like they somehow ended up larger radius, so you can see it's getting caught on the pulley in the middle there. I could print smaller ones, but I think I'm gonna put this on hold and hope for the best with the regular wheels for now. One thing I probably should have been considering more is the actual floor material I'll be competing on. They say it's plywood. I feel like that could mean a lot of different things, like you got like particle board plywood, which is pretty rough, or you know, you could have like nice finished plywood, and that's pretty smooth, like this floor. I think that could make a big difference on the wheels, but it's hard to test ahead of time. The floor I've been testing on is pretty slippery, so that means it's less grip, but it also means it should be easier to push things, so maybe it kind of balances out. I am not sure. Something to think about. This wedge geometry is really starting to push the limit of what can print nicely. There's like a lot of messy support material to tear off. It's gonna be kind of difficult to get this to come off clean. All right, so the new wedge doesn't actually work because they only get about that much under, and it's not able to, you know, push the robot all the way up to the top here. It just kind of does this and then stops, or sometimes it's able to push from here, but either way it's not doing this like it's supposed to. So I think I'm gonna go radio silent for a bit. Stuff just like isn't quite clicking like I want it to, and I think you get the idea, where come up with an idea, try it, either it works or it doesn't, and I don't want to have to think about recording everything at the moment over these last few days. So I think I'm gonna stop, and then, you know, whatever we end up with, I'll do a recap of how we got there. Like, worst case scenario, I'm fighting with this and it's a robot and it's done. Best case scenario, I fix all the problems, and then I'll just, you know, explain what changes have been made. So, see ya in a couple days. All right, it'll be the day of the competition in like 15 minutes. So here's where we're at. We have kind of regular robot. It's a little bit in pieces. I got eyeballs on it now. I printed a wedge that's like the biggest we can be with this setup, with this weight, to hopefully lift the other robots up high enough. And that's ready to go. I printed like 2 of those. One of them is printing right now. We also have this version with the wheels sticking out the back. And this is lighter, which lets us have a bigger wedge that I'm also printing right now, and trying to print a second set of these. My printer has been having issues getting clogged, so I am also recruiting my friend's printer, who's working overnight tonight as well. So essentially, we have the basic robot ready to go, and we'll probably have a slightly improved one, maybe 2 copies of the slightly improved one. It all kind of depends on how well the prints go. But not a bad place to be. I am very tired though, and need to wake up early. and then we do competition. It's gonna be a lot of fun. I've had lots of nice help from some people today, so thank you to them. Yeah, see you there.